So good evening everyone. Today I will discuss about in this video related to the limits of flammability and explosive limit. Then after that we'll cover about related to LEL, lower explosive limit, and after that we'll cover about UEL, upper explosive limit. Then we'll also cover related to the some gases which is present in the atmospheric condition related to the same like LEL and UEL. Then we'll also cover about the detectors. So these are the points which we'll cover in this video. Okay. So first we'll start with limits of flammability. A flammability limit is the concentration, is the minimum or the maximum concentration. Okay. The minimum or maximum concentration which is related to the range. Okay. What amount of range over there to start the ignition source from that point. So the flammability limit is the concentration range of a gas or vapor in air that can catch fire or maybe explode as well. That can catch fire or explode with a spark or flame if suppose it is present over there. If suppose you are working in a confined space, tanks and all. And the flammability limit or the minimum concentration of air which is mixed by volume with the fuel as well as air. And if you go over there in the tanks, containers, and if you give an ignition source, there may be the possibility it may blast and also maybe explosion type. Okay, it may blast and explode. That is what the thing. So if the ignition source is present over there, it may blast. It may can catch fire. It has two parts like the lower and upper explosive limit, which we'll cover. Okay, so lower explosive limit, the lowest concentration of a gas or vapor in air which is capable of producing a flash or fire in the presence of an ignition source, which comes like examples like arc, flame and heat. And the upper explosive limit says the highest concentration of a gas or vapor in air capable of producing flash or fire in the presence of an ignition source. So it is clearly mentioned that the LEL and UEL, the lower explosive limit or the upper explosive limit, which relates to the gas which is present with the minimum concentration or the maximum concentration by the volume of the air only. Okay, so it is mixed together and it forms a combination, a mixture which mix up together, and then there may be the possibility it may explode, it may can catch fire. So these are the things which comes under LEL and UEL. Okay. Then we'll discuss about examples of flammability limit in air. So these are the things which is related to fuel. Okay. Then we'll also cover related to the physical state, the lower limit and upper limit. So first we'll cover related to the hydrogen gas. Hydrogen basically it's a gas. So physical state says it's a gas. The lower limit which says related to the 5% and upper limit is 75%. So in between this range, if you are working in the same condition, and if you go inside the container and if you go with the like welding and cutting and all, that kind of job you want to do inside the compartment. So once you light it, the torch of that same, there may be the possibility that it may explode over there. Okay, so that kind of range which says lower explosive limit and upper explosive limit, so that calls dangerous job or the dangerous limit or the explosive limit range. Okay, then here simply we'll go with the other gases as well, like carbon monoxide. Yes, it is again gas. The minimum concentration of air which mixed together, that is not 12.5%, and the maximum concentration of air which is mixed by volume, that is 74%. Okay. Then methane, again it is same, the gas. The minimum concentration of air which mixed together, that is about 5% by volume in air, and upper explosive limit which says 15% which mix up together by volume in air. Then propane, again it is gas, the same concentration, the lowest concentration of air which is mixed by volume. Okay, So that is what 2.5%. And here the maximum concentration which is mixed by volume, that is what 9.5%. Butane 2%, that is what the lower explosive limit, and 8.5% that is upper explosive limit. Then ethylene you can say it is gas, 3% is the lower explosive limit, and 32% is the highest limit, means upper explosive limit. Acetylene gas, again 2.5% is the lower explosive limit, and upper explosive limit, that is what 80%. So if you are working in this range, that calls the explosive range. If you go inside, just apply a torch, maybe gas cutting, maybe grinding, or maybe welding and all. If you are going with the hot work, it is again very important, always you have to check the limit. If you are working in this zone, you light it, that material, it may ignite, it may blast, it may explode. Understood? Then carbon disulfide, ethyl alcohol, which comes under like vapor from liquid. Yes, these are the different liquids. When the liquid, the forms of liquid which is converted into vapor, okay, so the chance of vapor which goes related to the LEL, which says 1.3%. So once the vapor started igniting, if you give a spark in this level 1.3%, that is what the carbon disulfide, or ethylene which says 4.4%, the lower explosive limit, and upper explosive limit says 19%. For carbon disulfide, again it is vapor, comes from the liquid, so lower explosive limit is 1.3%, upper explosive limit says 50% by volume. Petrol, vapor from liquid, 1.4% to 1.4% is the lower explosive limit, and 7.6% is the upper explosive limit. So this is what the minimum concentration of air which mixed up by volume, okay, and this is the maximum concentration which is mixed by volume in air, okay. So this calls lower explosive limit and upper explosive limit. Paraffin, vapor from liquid, 0.7%, which is again mixture of the same concentration by volume in air, and 5.0, which is the upper explosive limit. Diethylethane, vapor from the liquid, 1.9% is the lower explosive limit, and 36% is the upper explosive limit. And here, most important thing, if you are working in hydrogen sulfide area like H2S zone, it will be very deadly. So H2S is what, basically it's a gas. If you are working in this range calls LEL, lower explosive limit of H2S is 4.3%. If you are working in that kind of range, always go with detectors. Put the detector down, check the level of the gas, okay, and never light any welding rod or any gas cuttings. Don't light any kind of material. If you light it, again it may explode, or it may blast and all. So this comes under LEL of H2S, lower explosive limit, and this is upper explosive limit. So the minimum concentration of air or the gas which mix up together by volume with a proper concentration. So that is what the mixture says LEL, or the maximum concentration. The maximum concentration of air which is mixed by volume, okay, that calls upper explosive limit. So this is what the main difference between LEL and UEL, related to the gas, related to the liquid which comes under vaporization forms, okay. So these are the things which is very important. Be very careful, always go with the detectors, okay. Put the detectors down, check the level. There are different kinds of detectors. We have multi-gas detectors. We have a portable type, which you can put in your pocket and then you can roam here and there, okay. And we have other detectors are fixed type detectors as well, H2S detectors, okay, other combustible gases detectors. So we have different kinds of detectors. Here you can easily understood about this graph, okay. This is what the range of H2S. Here the range of H2S is 0%, and the range of air is 100%. Now suppose you are working over here. This is what the free zone. There is no any toxic gas over here. In this is what the range called normal, free zone. Understood? if you went inside the compartment, once you entered inside the confined zone due to the manhole, here is the manhole. So once you entered from here, where is the ladder? So once you entered inside the confined zone, okay, and the level of H2S is 4.3%. If the level of H2S is 4.3%, do not use any hot work type of equipment like welding, gas cuttings. Don't do any hot work over there. If you do hot work over here, this is the zone where there may be the 100% possibility or chances that it may explode, can catch fire. Okay. So this range called LEL, lower explosive limit, is the minimum concentration of air by volume which is mixed together. Okay. And this is called upper explosive limit of H2S, 46%. So if we are working in this zone, this is called explosive range. This is called explosive range. So be very careful. Always go with detectors. Do TBT with your team. Toolbox talk. Take permit. Okay, permit to work is very important. If you want to start your job inside the compartment, first take permit from the safety officers. They will go inside, they will check each and everything, purge your tanks and containers, do purging, nitrogen purging or fresh air you can put it. Put the detectors again, check the toxicity of the H2S or the other toxic gases. There may be the possibility that other gases as well, so check it. Put the detectors over there, check each and everything. Once everything clear, then you have to start your job. Understood? So if you are working in this zone, this is what the free zone. Once you enter inside the compartment, there may be the possibility that H2S in the lower explosive limit, with the minimum concentration say 4.3%. So if you are working in this zone, be very careful. Always go with SCBA set. Always you have to go with SCBA set, self-contained breathing apparatus, which protects your life. Okay? If you inhale certain amount of ppm level of H2S, maybe like 30%, maybe 40%, you may die over there. Understood? 1 ppm, 2 ppm, 5 ppm, 10 ppm, 10 ppm is also dangerous. Percentage level is like max. So if the ppm level says like 50 ppm, 100 ppm, then also you may lose your life over there. That is what the ideal is. Immediate dangerous to life and health. That is what you can say deadly. So if the level of H2S is 4.3%, it means that if you do not go with BSA, immediately you will die over there. So be very careful. Always go with the SCBA set, rear SCBA set, and then go inside to work or for the rescue or for the firefighting purpose. So this is what the things. This is called LEL and UEL. Here the range called explosive range. If you cross this range, here the air is 0%. So there is no chance of fire. There is no chance of fire. Why there is no chance? Because the fire triangle says fuel, heat and oxygen. The fire triangle says these are the three elements. Fuel, heat and oxygen. If these three elements are present in proper proportion or in a right mixture, then only fire can take place. So here there is no mixture. There is no formation of triangle. Why? Because air is 0%. So here says the fire triangle says these three elements, all these three elements, fuel, heat and oxygen, if these three elements are present in proper proportion or in a right mixture, then only fire can take place. If one of these elements are not present in proper proportion or not in a right mixture, then it will automatically go off. So due to this, there is no formation of triangle. So in this area, if you cross this limit, so there is no chance of triangle formation. Only the hazard is what? The hazard is H2S. You may die because the percentage level of H2S is 100%. So you will immediately die once you went inside, like the percentage level of H2S is 100%. If you take a single breath, that's it, that is much enough. No one can save your life because the range of H2S is too much, 100%. But this is not the explosive range. This is not the explosive range. You will die because of presence of H2S. But there is no chance of explosion, there is no chance of fire, there is no chance of blasting and all. The range, the specific range says LEL and UEL is proper mixture says 4.3% for LEL and 46% for UEL, upper explosive limit and lower explosive limit. So if we are working in this range, this range called explosive limit zone. So if we are going inside the confine and the range which says related to the presence of air in between 4.3% to 46%, that range is the explosive zone. So be very careful, always go with proper protective measures, go with SCBA set, okay, do HIRA, hazard identification and risk assessment is very important, okay, or either you can go with JSA, job safety analysis. So these are the things which is very important, okay. So always follow all the safety procedures, okay, standard operating procedures. Go with pre-inspection checklist. Pre-inspection checklist is over there. Go with the checklist. Check, put the detectors down, and follow all safety protocols. And if any kind of emergency occurred inside, immediately come out and report to the senior officers. Understood? So that